In this problem, we are looking at a scenario where we have the plane travels 200 miles west, 350 miles south. Find the magnitude and direction of the plane from its current position to its start, which is the origin. Okay, so we have a plane traveling 200 miles west. So I'm going to go ahead and draw in going 200 miles west. That's going to be negative 200 because we're going west. And then we are going 350 miles south. So it's going to be negative 350 because we're going south. And we want to find the magnitude and the direction. So magnitude and direction. And what we mean by direction is like the degree amount. So this value right here, x degrees, whatever that's going to be. So magnitude is going to be found by using the distance formula. Okay, so we have negative 200, negative 350. So we want to use the distance because we want to know, well, how far is it from here to here? So we want to know what is the distance that it traveled, the magnitude, so from here. Okay, so we're going to do, that's bad. So we're going to take, it's going to be negative 200 minus 0. I'll write it out. Plus negative 350 minus 0 squared. So that's the distance formula. Negative 200 minus 0 squared plus negative 350, 0 squared. So that's just going to come out to be negative 200 squared. And I didn't necessarily have to write this, but I'm just going from here to here. So negative 200 squared and then negative 350 squared, just showing you all of the ins and outs here. And then I'm just going to my calculator here. So 200 squared plus 350 squared, because negative times a negative is going to be positive. So I'm just going to do 200 squared plus 350 squared is the square root of 16 to 500. And then the square root of that number is going to be 403.11. So it traveled 403.11 miles. That would be the magnitude. The magnitude of a vector here that we're looking at is the distance. So the distance is 403.11. And then the next part of the question is asking for the direction. So we are going to take this value. And what are we given here? If we have a triangle, we have a right triangle. We have this x value, this unknown that we're trying to figure out. Because we want to know the degree amount. What's the degree that it traveled from the origin to here? So we want to figure out which trig function we want to use. So we have this angle. This is the opposite side and the adjacent side. So what trig function are we going to use? We're going to use the tangent. So we're going to set up the tangent of x, or just x degrees, excuse me, is the opposite over the adjacent. So tangent of x is going to be, this is going to be positive because negative over negative is going to be positive. So the opposite side is 350 over the adjacent is 200. So how do we figure out what that x value is? We have to take the arctan. I'm getting a little close to my camera here, so I'm going to go up here. So the arctan is equal to so I'm going to do arctan of 350 over 200 is 60.3. So in 60.3 degrees would be this value right here. Kind of a tough problem just if you don't know the language, like magnitude is really asking for the distance of the vector because we're talking about a vector here. And then the direction, like how do you figure out the direction, would be the degree value. And if you want to get more specific, since it went west and then south, So it went 60.3 degrees, and I always want to make sure that I get this right. I think it's going to be south of west, I think would be the correct way we'd write that down. Sometimes they just say southwest, or sometimes it says south of west. Like, it kind of depends on what you're really doing. Like, some textbooks might address it a little bit differently, but I think typically we'll go with south of west. But this is plenty for the problem. This tells your teacher that you understand the concept of what we're trying to do. We're going 60.3 degrees, but which way? South of west. So I hope this helps. Pretty tough scenario there.